In this video, we are going to determine the equation of the tangent to the graph of f at x is equals to negative 2x squared plus 5 parallel to the line y equals to 8x plus 7. This is not a tangent. This line is not a tangent. Y equals to 8x plus 7 is not a tangent. But what we know is that this line is parallel to a tangent. Alright. So to understand this, let's put this in the picture. We are having a curve of f at x. And then somewhere along this curve, we are going to have a point of contact between the tangent and the curve. Here is the tangent, and here is this line. Y equals to 8x plus 7. It's not a tangent, but all we know is that it's parallel to the tangent. Okay? So this is the line of y equals to 8x plus 7. And this is the tangent. This is the tangent. In grade 10, you were told that the gradient of parallel lines are equal. Very good. So the gradient of this line is going to be the same as the gradient of the tangent. Why am I saying that? Because this line is parallel to the tangent. So they will share the same gradients because they are parallel to each other. So what is the gradient of this line they are talking? Y equals to 8x plus 7. What is the gradient of this line? The gradient of this line is going to be 8, because you know this is in the standard form y equals to mx plus c. So m is 8. So we know the gradient is going to be 8, the gradient of this line, of which is going to be exactly the same as the gradient of a tangent. So the tangent will also have the gradient of 8. So now, to determine the equation of this tangent, we are going to need the coordinates of the point of contact. But in the previous video, we just discussed how to find the point of contact. We said to find the point of contact, since we have the gradient now, we are going to say the gradient is going to be equals to the first derivative, so that we get the x value at the point of contact. What is the gradient of a tangent? It's going to be 8 as well, because it's parallel to y equals to 8x plus 7. What is the derivative? The derivative of f is going to be negative 4x. 5 is a constant, the derivative is 0. So this is the derivative of f at x. And then we solve for x. So if we solve for x, this is going to be x is equals to negative 2, because we are going to divide by negative 4 both sides. So we get x equals to negative 2. So now we know that at the point of contact, the x value is negative 2. How do we find the output, the y value? We are going to say we have the x value of negative 2. The corresponding y value is going to be f at negative 2. And then we do the computation. That will be negative 2 into negative 2 all squared plus 5, which will give us negative 3. Now we know that at the point of contact, we have negative 2 is to negative 3. Now we go to y equals to mx plus c, so that we are able to determine the equation of the tangent. And we use this information. We have the gradient of 8. We have a point. We have the gradient of 8. And we have a point. So let's do that. This will be in the form instead of y. This will be instead of x. This will be instead of m. So this is negative 3 is equals to 8 instead of m, negative 2 plus c. Then this will be negative 3 is equals to negative 16 plus c. Then negative 3 plus 16 is equals to c. Then therefore c is equals to 13. And then we conclude. Therefore the equation of the tangent will be y equals to 8x plus 13. This will be the equation of a tangent. We are using the fact that these two lines are parallel. So once a tangent is parallel to y equals to 8x, then we know that the gradient will be 8, which means the gradient of a tangent will also be 8 as a result of being parallel. Once we have that 8 as the equation, as the gradient of a tangent, then we can find the x value at the point of contact. Once we have the x value, we substitute to f, and then we find the point of contact. Then we go to y equals mx plus c and solve and conclude. All right.